This is a slightly difficult question that uses the vertical angles, the corresponding angles of parallel lines, the alternate interior angles of parallel lines, the exterior angles of triangles, and the sum of the interior angles of polygons, which are learned in junior high school. As usual, collect other angles around angle X. First, since it is the vertical angle, move 62 degrees. The sum of the interior angles of a triangle is 180 degrees, so subtract from 180 degrees to find this 45 degrees. And add parallel lines. Since the corresponding angles of parallel lines are equal, we move 45 degrees towards angle X. Similarly, 20 degrees can be moved toward angle X because it is the corresponding angle of parallel lines. Now we know that angle X is 65 degrees in total. I will show you another solution. Angle X should be found if you know the size of this angle. Find this angle using the boomerang shape. Since it is a rectangle, the exterior angles are 90 degrees. Also, since the sum of the interior angles of the upper triangle is 180 degrees, we know that this angle is 28 degrees. The vertical angle is also 28 degrees. In the shape of a boomerang, the sum of the three interior angles should give the size of the exterior angle. Subtract 28 degrees and 20 degrees from 90 degrees to get 42 degrees. After that, the sum of the interior angles of a triangle is 180 degrees, so let's find the size of angle X by subtraction. Two is a regular hexagon question. In a regular hexagon, opposite sides are parallel. In addition, draw a line parallel to these at angle X. Since the alternate angles of parallel lines are equal, we can move 42 degrees. Also, the next to 104 degrees can be found to be 76 degrees by subtracting from 180 degrees. This 76 degrees can also be brought to angle X using the alternate angle of parallel lines. Now we know that angle X in total is 118 degrees. Similarly, draw a parallel line and use the alternate angle to move angle Y to 80 degrees. If we know the angle next to angle Y, we can find angle Y. This angle is found to be the same size as the angle next to it, which is 67 degrees from the alternate angle of the parallel lines. Here, we need the size of each interior angle of a regular hexagon. You should be able to find the sum of the interior angles of a hexagon using the formula. Divide by 6 to find the size of one interior angle. I found out that one is 120 degrees, so now I know the size of the angle next to 67 degrees. The alternate angle of the parallel lines shows that this is also 53 degrees. Finally, subtract 53 degrees from 80 degrees to find the size of angle Y. I will introduce another solution. Since the sum of the interior angles of a quadrilateral is 360 degrees, this method finds the angle next to angle y. Using the same method as before, we know that the size of one interior angle is 120 degrees, so we subtract all these angles from 360 degrees to get 51 degrees. Subtracting 51 degrees and 42 degrees from 120 degrees gives us 27 degrees remaining. Next is a question using line symmetry. The axis of reflection is a line like this, so we know that the size of x is 120 degrees. Because of line symmetry, the size of y can be found by finding only half and multiplying by 2 at the end. 80 degrees is half to 40 degrees, and the sum of the interior angles of a quadrilateral is 360 degrees, so if we keep subtracting, we can get 130 degrees. Since it is an exterior angle and next to 130 degrees, we know that it is 50 degrees. Multiply this by 2 to find the size of y. Two can be solved in various ways. I will introduce a solution that seems to be useful. Connect the dented parts with lines to form a hexagonal shape as a whole. The sum of the interior angles of a hexagon can be calculated, so it seems that we can create an equation. Using point symmetry, add a known angle. There are also 2x. If we want to create an equation with the sum of interior angles, we need these green and orange corners. We do not know the size of each of these angles. I don't know the size of each angle, but I do know the size of the combined angle of green and orange. The sum of the interior angles of this small triangle is 180 degrees, so we need to subtract 105 degrees from 180 degrees. Subtract to get the remaining angle, which is the angle of green and orange combined. Finally, let's subtract from the sum of the interior angles, 720 degrees, to calculate 2x angles. Finally, divide by 2 to find the size of x.